Hello, friends. We're about to start talking about logarithms in our course, but before we do, I want to talk about the laws of logarithms, which are on our formula sheet. So if you don't have your formula sheet with you, I want you to hit pause and go find it. I'm going to tell you where these laws come from. Now, none of this information is in our books, but it's really going to help you understand where these laws come from. And if you understand where the laws come from, it's going to help you as we work through this unit. So nothing really to write down here. Just go grab your coffee, sip it, watch this real quick video. I'll try to keep it to 5 minutes for you. I think it's going to help with the entire unit and what logarithms are for. Okay, logarithms. The reason why we are going to use logarithms, we're going to use logarithms to help us solve for unknown exponents. So we're going to use logarithms to help us find what x is in a question like this where we can't make bases the same. But before we do that, we need to know where these laws of logarithms come from. Okay, first off, what is a logarithm? A logarithm is a complicated function, just like sine is, and cosine, and square root. You know, we hit these buttons on our calculator. Our calculator gives us an answer, but we really don't know what that is doing in the background, do we? A logarithm, a log on your calculator is going to be the same thing. So I just want you to keep that in mind. It's a function. When we press this log button, your calculator's doing a pretty difficult calculation. No big deal. Okay, so what the heck is a logarithm? Well, going back to the history of trig, the scientists were working with radians. They were talking about stars on the horizon, and we don't need the whole part of the history lesson. But what I need you to know is they were doing this. They were scientists, right? And so they were working with these kind of crazy looking numbers in radians. And because they're scientists, they're whatever they were measuring, they are going to do it, 1,000 times to be as accurate as possible. And doesn't really matter why, but what they were trying to do was they had to multiply these numbers together. Can you imagine without a calculator having to multiply that together? And there was more than just say 5 of them like I've drawn here. This is the 1600s. At best, they have an abacus. So multiplying this together was impossible. Impossible, but they're going to make a lot of mistakes. So it was slowing down the work. So this really smart guy, Napier, and another guy, so a French guy and a Swiss guy, get together and they're sitting around the campfire one night and they say, oh, this multiplication's killing us. But if I could just add these things together, like I could add these things when I was in elementary school. Wait a minute. What if we turned multiplication into addition? So they're sitting around the campfire and they have this great idea. Let's turn multiplication into addition. So essentially what they end up doing is they create something called a logarithm, which allows them to do it. So that's what the whole purpose of logarithms was. The whole purpose of logarithms was to turn multiplication into addition. So they would be, let's just look at something even basic. 3 times 5 times 6. Okay, that's 90. But their goal was to turn this into addition. How did they do this? They created a function known as a logarithm. And so this is what they created. They said we can turn multiplication into addition by using this brand new function called a logarithm. Just like that. Now again, this is a function. It's complicated. We're happy we have a calculator, unlike these two fine gentlemen had. Okay, let's look at the rules of these things. So rule number one on my formula sheet. We actually just figured it out. The goal of logarithms was to turn multiplication into addition. So if I said log 2 times 13, well, what this is telling me is this is log 2 plus log 13. That's it. So the law you see on your formula sheet is this. Log m times n is equal to log m plus log n. There's law number one, the product law of logarithms. Well, friends, it's not too far of a leap then to say, if multiplication turns into addition, what do we think division will end up being? Well, let's go log 9 divided by log 2. Well, if multiplication turned into addition, you're probably saying, I bet you this turns into subtraction, and you are correct. So there's law of logarithms number 2 on my formula sheet. Log m divided by log n is log m minus log n. Law number 2 on my formula sheet. Now, the third and probably most important law is this one, the one that looks like this on my formula sheet. The power law. Okay, this is a funny looking law. What the heck's going on here? Well, what this is saying is we can take a coefficient and make it an exponent. What? Where does that come from? Well, it actually relates back to the fact that multiplication turns into addition. Here's an example for you to show you where this came from. Let's go log, I don't know, 2 times 2 times 2 times 2. Well, I know what that is. That's log 2 times 2 times 2 is 16. But I'm going to use the fact that the goal of logarithms was to turn multiplication into addition. So let's rewrite this out. That would just be this, 4 times, wouldn't it? All right, so what? Well, now let's rewrite this a little better. 2 times 2 times 2 times 2. Wait a minute, that's 2 to the exponent 4. Let's look at the right-hand side. Log 2 plus log 2 plus log 2 plus log 2. That's 4 log 2s, right? That's 4 of them. 1 plus 1 plus 1 plus 1. That's 4. Well, wait a minute. What do you notice? My exponent is the same as my coefficient. And there is my power law of logarithms, that my coefficient can become my exponent. There it is, friends. There is your 3 major laws of logarithms. So all I need you to remember, the French guy and the Swiss guy's goal was to turn multiplication into addition. They did it with a logarithm. Then division turned into subtraction, and because of that, we end up with this, which is going to be probably our most important law in this unit, because that's how we're going to solve for unknown exponents in questions like this. There is your history of logarithms.